Hello everyone, welcome back to the channel. Now in this video we are going to start with a new data structure, that is heap. We already discussed about binary search tree and about AVL tree. Now heap is also a special type of binary tree only, which mainly follows two rules. Okay, now what are those two rules? So first of all, it's a complete binary tree, which means every level except for the last level is filled. It is filled left to right. So there won't be any node in the tree where you have a right child, but you won't have a left child. There will be no such scenario for heap. And the rule number two is value of the node is greater than its children. That means whatever node you're picking, right, the value of that node will be greater than its right and left children. That means left child and right child. Okay, there is no such thing followed like binary search tree has key left node should be less and right node should be greater. There is no such condition for heap. Okay, the only condition, it should be greater than both of the childs. So those are two rules for the heap. Okay, now we have two types of heap, that is min heap and max heap. Okay, it is used for sorting, finding min and max. This is actually a really big use case. You will be using it at lots of different places. Even in graph algorithm solver, you'll be using this heap concept. So as we go ahead, we'll understand more about it. Okay, so there is an operation we do for bubbling up and bubbling down. That is basically when you're doing the insertion, right, of any element, you understand if that is a correct position of insertion for that particular element or not. For let's say in case of max heap, if the value that you're trying to insert is greater than its parent, then you try to move it up. That is, you try to bubble up so that it finds its correct position. Similar thing again when you're trying to delete the element, right, which can only happen from the root. Okay, so the moment you delete the root node, you have to fill that position with the last node from the tree. And when you're moving the last node from the top root node, right, that might not be the correct position for that particular root. Okay, most of the case it is not. And then what you have to do, you have to bubble down for that particular node. You have to find a correct position where that node is supposed to go. So that is called bubbling down operation. So those two operations are basically what we are interested in right now. Okay, and we'll be doing this implementation using array. Because array is less costly, we don't have to deal with the concept of having extra node class. Okay, and this looks clear because your nodes that you're doing insertion, right, are in sequential order. So that's why array seems like a good data structure to implement it. So let's go ahead with the implementation of the insert operation. Private int, first let's take our items array, where we are actually going to store the values of our heap. Let me initialize it with 10 for now. And now let's create our insert method. Public void insert. Let's create our size variable as well. Private int size. Obviously this variable will be initialized with 0. Now when you're trying to perform insert operation of that particular value, so how you can do that, items of size plus plus is equal to this value. First it will assign that particular value to the size, this index, which is for the first item 0, and then it will increment the value of the size variable. Okay, before that we can check one more thing. If your size is equal to items dot length, that means your array is full, your heap is full, you cannot add any more elements. In that case you're supposed to throw new illegal state exception saying that heap is full. Now we need to actually see the element that we're trying to insert, right, is placed at its correct position. Okay, so for that we need to implement that bubble up operation. How do we do that? while the index. Now how do we get that index? We can get that index by index is equal to size minus 1, because this size would be the correct index where you actually inserted the current value, and I'm doing size minus 1 because that will be the, we all also did the increment, right? That's why to find the correct index, we are doing size minus 1. Okay, now what is the condition for it? While index is greater than 0 and now I greater than 0. If we do it greater or equal to 0, that means for parent index we are going to get the negative value, which we don't want. That's why it's greater than 0, not greater or equal to 0. So if the index is greater than 0 and the value and this particular index is greater than value at its parent index. Okay, so to get parent index, the formula is, okay, int parent index. The formula to get the parent index is index minus 1 divided by 2. So this is the formula to get the parent index. Actually, we can get it in a method. Okay, so we have created our method to get the parent index, and then we can pass that here and pass that index value. So we are checking if index is greater than 0 and the value at that particular index should be greater than the value at its parent index. That is when we have to swap them. Okay, so I have copied this swap method from the other program. We already implemented a lot of sorting algorithms. Okay, now what are we doing here? We need to replace the value in this particular items array for this index and the parent index. Okay, get parent of index. That's correct. Now what do we need? We need to change the value of index. Now this index will become parent index. Yeah. So now this became a parent index. Again, it will, this will keep on looping until the element that we are trying to insert at its correct position. This is the insert operation, and this is what we are doing is what called this bubbling up operation. So we can actually place it in a different method and name it properly bubble up, so that we know what we are doing here. First, what you're doing, if the array is full, you're telling the caller heap is full, then you're doing the insertion at that particular index. If the heap is not full, then you're calling the bubble up operation, and bubble up operation is actually finding the correct position for that particular element, and that's it. It's placing it there. That's all it is doing. So if we are good with insertion, let's create our main method and see if we are implementing this correctly or not. Alpha heap is equal to new alpha heap. Okay, now let me add some values here. Okay, so I have added 10, 5, 17, 4 and 22, right? Now as you can see, I have added 24 in the last. So if our bubble up operation is working properly, right, then we are supposed to get this 22 on top, because we are actually implementing max heap. Okay, so let's try to debug it and see if we are able to get 22 on top or not. If yes, then we have done the implementation right, and this is our max heap and our implementation is fine. Okay, we have 5 elements. That is correct. 1, 2, 3, 4, 5. And what do we have on top? We have 22. So through this you can see properly that 22 is on top. The left child is 17, the right child is 10, which is correct. And again, the left child of 10 is 4 and right child is 5, which is following both of the properties. Okay, it is a complete binary tree and every single node value is greater than its left and right child. So that is a max heap for you. This is how you do the insertion in max heap. Okay, in next videos we'll be implementing more operation. That's all as part of this video. See you in the next one.